So in number 43, we've got Io, a satellite of Jupiter, has an orbital period of 1.77 days and an orbital radius of that. From this data, determine the mass of Jupiter. Again, remember, for anything in orbit, centripetal force is equal to force of gravity. In this case, we're given the period and the radius. So for centripetal acceleration, I'm going to use this equation. So the centripetal force, just the mass of Io, times the centripetal acceleration, is going to equal the gravitational force, which is going to be g times the mass of Jupiter times the mass of Io all over r squared. And I left it this way. Please notice that the mass of Io is going to cancel out. And rearranging the equation to solve for the mass of Jupiter, multiplying both sides by r squared, you'll move over there, dividing both sides by g, it ends up in the denominator. And now I can very quickly and easily solve this by plugging in the numbers. One little quick note here, I've got to convert days into seconds. 1.77 days is going to be this many seconds, realizing that there's 86,400 seconds in a standard Earth day. Plugging in our numbers, we've got the radius, don't forget to cube it, 4 pi squared over g times this period that we just came up with up on top squared. Plugging in all the numbers, you'll discover the mass of Jupiter is about 1.90 times 10 to the 27th kilograms, which ends up being substantial, but still about 1/1000th that of the mass of the Sun. Jupiter is the biggest planet, but it still is dwarfed by our Sun. I hope this helps.